All right, physics dorks, here we go. Real quick explanation of the plan for the week or the rest of the week, whatever else. Today you're doing that catch up stuff, whatever else, and then or on Monday, whatever. So this is the discussion right now for Tuesday. Videos, video of X-rays and Chernobyl, blah blah blah. So a little bit of a talk, and then we'll talk again tomorrow. And then we're going to talk about the blue sky and tell you why the sky is blue and blah, blah, whatever else with that. And we're going to try and have a quiz on all this stuff on Friday. So on Thursday, what I will do is kind of wrap everything all up together and discuss it and give you kind of a review. And then if it makes it for Friday, it's Friday. Otherwise, we'll do it next week. So I'm not sure how long this is going to take. But anyway, that's kind of the plan for the week. So aim for a quiz on Friday. Not sure if it's going to get there, but I'll let you know. Okay? So like I said, Monday's kind of a catch-up day. Hopefully you got that stuff done. And here's today with the X-rays and whatever else. So if we go to our notes, just reviewing really quick here, the radio waves, looks like you guys got a really good idea. The idea is that these are all electromagnetic waves that traveling at the speed of light and using electricity and magnetism to propagate a wave of energy. And you came up with how those work. And what I'm going to try and do is I'll do a little more. I'll do a short video of a little more on radio waves. See if I can get up my attic and show you my antenna. But anyway, yeah, that's kind of what I was going to show you up in the attic or whatever else, how the antenna actually uses the radio waves to pick up information. Microwaves, whatever, you hopefully got a good explanation on that one. Exciting any water molecules inside and bouncing around in there. And no, it's not going to give you, you're not going to get cancer from standing next to the darn thing. So, yeah, it's just another form of electromagnetic waves, exciting water molecules, but and then visible light, again, kind of, that's the one. You hopefully watch that video clip that it's a very, very small part of the entire electromagnetic spectrum. UV, and those are the ones that they actually can use. They're small enough. We start getting into the damaging portion of the spectrum where these things here will actually start shredding apart DNA and cell structure. And, as you go even smaller, there's more energy and you get into the X-rays. And the idea is that these here have enough energy, they can actually travel through the soft tissue of your hand. And what they'll do is they react with photographic film on the other side. And so that's why they put that film on the bottom underneath you, or they slide that big sheet in there. They put it at the side of your head or in your mouth when you're getting X-rays of your teeth. And that's what it does, is it exposes the film on the other side. And this right here is blocking the X-ray from going through. So there's a reason why this dude right here is on the other side of the wall, because what will this stuff do to your cells? Same thing as the rest of it, the UV and the gamma, they are deadly for cell tissue, DNA. You don't want to get this over and over and over again. It could be an issue. Where you step to next are these boogers right here. Now, watch these video clips and watch this on, this is just, how unbelievable different parts of Europe are. But the idea is, here is the penetrating power of gamma rays compared to everything else. And so the idea is that, you want to have something between you, but look what, gamma rays can get through all the way to, this is why you want to hide in your basement after a big nuclear blast. Okay? And the gamma rays are off. They're, we find them all over the place, but where they really come from is the breakdown of nuclear material. Now, if you have not ever heard of Chernobyl, oh my God, we need to really, you really need to look at some of this information, this stuff. There's all kinds of video clips on YouTube about this. The coolest thing you need to watch, though, if you want to spend the money, you ask anybody that's watched this series on, I think it's HBO. It's actually on Chernobyl, and in the IMDb rankings, they put that up there as one of the best little miniseries. I think it was like 5 episodes or whatever. Extremely, extremely well done. If we were in school together, we'd be watching it at the end of the year because it's extremely well done. Talks about the science and the destruction and everything that went with it. It's extremely well done. So watch it if you can. Spend the cash. You got tons of time now. You wing nuts. Do it at night, during the day, whatever. But Chernobyl on HBO, 5 episodes, extremely well done. Okay. All right, and they're just showing here as far as all the places that it affected and still affects and whatever else. So what we'll do tomorrow is we're going to talk a little bit about polarization in thin films, but where I want to get to, I should talk a little about lasers too. Want to get to is really at the end there talking about reflection of light. So like I said, I'm not sure if we're going to make the test on Friday, quiz on Friday. So whenever we get to it, we get to it. Okay. All right, kids, watch your stuff on Chernobyl, and we'll talk tomorrow. Okay. Bye.